Good morning all. The screen is visible and am I audible? Just let me know into the chat box. Okay, fine. So today we are going to discuss another topic of partial derivatives. That is what? Total derivatives. So in last lecture we have seen the derivatives of what? Higher order, right? And we have solved some example, and mostly in that kind of the proof, okay, or you need to prove something kind of example is supposed to be asked. Now in today's lecture we are moving to the new topic of the same chapter, same unit, right? That is total derivative. So is there any problem in last lecture, previous lecture? Is there any doubt, anyone? Right? So, okay. Yeah, Dev Patel. Yeah, Dev. You can unmute yourself, Dev. You have raised your hand. Okay. Dev Patel. Is there any doubt? Sorry. Okay, fine. So maybe by mistaken you have raised your hand. So today we are moving to the new topic of this thing, total derivative. In that one, the first concept is chain rule. Before moving to the definition of total derivative, we'll briefly discuss what is chain rule in what partial derivative. So for example, Z. Suppose Z is, by mistake, I have stayed muted. Okay, just a minute. So if you are having doubt, we'll discuss in last 5 minutes because I've started, right? So Z equal to f of u. Suppose Z is a one function of what? F of u. And u is a function of u is a function of what? X and y, right? Like this. So what we can say, z equal to f of u, and u is a function of two variables, that is which one? X and y. So see, z is a function of u, and u that will depend upon two variable, that is what? X and y. So this is just a given, right? Z that will be depend upon u because z is a function of f of u. U is a function of what? X, y. So it will be depend upon x, y both. Fine. So if you want to find out a del z by del x, so you can see from the figure. For Z, you will go with what? Through what? Z, U and then X. Okay. And the one direct way is from what? Z to X. That means if you want to find out del Z by del X, then in which way you want to go? First you want to go for what? Z to U and then U to X. That kind of thing, right? So indirectly we can say what? Z is depend upon two variables, that is nothing but U and V. The Z will be dependent, okay, indirectly. Now here, if you see from the figure, Z is depend upon U, okay. So now there is in definition, we are going to use a partial derivative and ordinary derivative, right? So that is the important thing where you are supposed to put a partial and when the ordinary, right? So that is, you need to take care for that. Now here, del z by del x, if you want to find out that, right? Del z by del x. So how you are supposed to write? First you have to reach to u. So we can say that z is depend upon only one variable, that is what? U. Okay, directly it will be depend upon what? U, but there is a path for z to x is via u. So what I'll write, when there is only one dependency, we are supposed to use ordinary differentiation. So dz by du, okay, into here u x, the next, this is my first rule, then I'll use this path, right? U to x. So see, u will depend upon two variable, which? X and y. U will be depend upon two variable x and y. So I'll write what? Del u by del x. Fine. So if you want to find out del z by del x, if you want to find out del z by del x, the equation will be, sorry, the equation will be used, that is which one? This, which d by dx, this is ordinary derivation, into del u by del x. Clear? Is there any doubt? Any doubt in this equation? Now suppose I want to find out del z by del y. This. If I want to find out del z by, this is what? Del z by del y. This is del z by del x. So if you want to find out that, so what is the first one is this, right? Z to u. That means z is depend upon u. So when there is only one variable, use the ordinary dz by du into del u by del y. Okay, because u will be different, u will be depend upon two variables. Fine. So what? Sorry, here it's a y. So this way, one is what? Del z by del x, and another one is what? Del z by del y. And this is the equation, right? Any doubt into this? So this is called a chain rule. If you want to find out z to x, you have to go via what? U. Fine. So when you are supposed to write a ordinary derivation and when you are supposed to write a partial. Is there any doubt, anyone? Just let me know into the chat box. Is there any doubt when you are supposed to use ordinary and when partial? When simple in language, when there are two variable independency, you have to go for partial. Otherwise, you have to go for the ordinary. That means the direct derivative, right? So this is called a chain rule. Now, the definition of composite function of one variable, right? So suppose in that one, u equal to xy, f of xy. That means now u itself is depending upon two variable. I'll draw the graph also with that, so it will be clear. U will be depend upon two variable, what? X and y. Now x and y, that variables r is a function of x equal to phi of t. So what is the meaning of this? X will depend upon only one variable t and y equal to chi of t. That means it will depend upon a y. That means what? X and y both are depend upon the one variable, that is t. Clear? This is a representation in expression. This is the graphical form. Right? So what we can say? U is a function of t is called a composite function of one variable. Right? Because if you want to find out, a if you want to find out what? This direct, right? Del u by del t. So how you are, sorry, du by dt. So how we are going to do? Right? Okay. Is there any doubt? Fine. So what we can say, this u is called a composite function of single variable t. Right? So how to define it? So du by dt. Because you can see from the diagram, u will depend upon what? T directly. But the way which you have to go via x and via y. There are two paths now, right? Two paths are there. So how we are supposed to first will consider this path via x. So now this x, right? So first I need to write what? Del u by del x. Why? Because u is depending upon two variables. So I'll write what? Del u by del x into, for this part, I'll write what? Dx by dt. Why? Because only one variable. For t, the dependent variable is only one. So what I'll write? Dx by dt. Clear? Now second part. So for that we'll write what? Plus sign. For that we will write what? Plus sign. Now this du by, okay, either du or del. So we'll use what? Del u by del y. Why? Because u is depending upon two variables. So what I'll write? Del u by del y into, this is y to t, only one variable. So I'll write what? Ordinary dy by dt. So you can see this. These two are the ordinary differentiation and this are a partial, right? So when this is type of thing is there, so you have to consider, you have to take it in this form, fine? So how to find out du by dt? This, this is called a total derivative of u. So this is, right, definition of total derivative. Any doubt into this? U equal to fxy. X and y both are a function of t. Now if you want to find out du by dt, that is called a total derivative of u. So that can be written as a what? One path is this and second path is this. So you have to consider both path and you have to write down in terms of this, either ordinary or partial. Okay, is there any doubt? Just let me confirm in a chat box. Or you can raise your hand if you are having any doubt quickly. Otherwise, we'll move to the example. Okay, fine. Okay. So example for this is, okay, I'll check. Okay, fine, no doubt, fine. So example for this is what? Suppose I'll be having, I'm writing here only, right? Example. So u equal to y square minus 4ax, where see u is a function of what? X and y both. Now x equal to at square, y equal to 2at. So the question is what? Find out du by dt. Find out what is the difference between du and dx. Okay, maybe just we'll go through with this example. So maybe it will be clear. Otherwise, we'll go in the another way, right? Right? Okay. Now, this, see, they are the different function you can say, right? U is a one function, will depend upon two variable x and y. Now x and y also are a function which will be depend upon which variable t. So you can see that this diagram is same for this. That means what? U is a one function which will be depend upon two variable x and y, and here there will be a t. So that will be like this. Okay. Now what you want to do, you want to find out what? Du by dt, this. So du by dt, sorry not del, du by dt. So if you want to find out this thing, right, du by dt, so there are what? Two way, and you have to consider both. The first one is this via x and second one is this via y. So how you can write? It is same as the previous equation, right? What I supposed to write? Del u by del x into dx by dt, because only one variable t. So I'll write dx by dt plus del u by del y into dy by dt. Is there any doubt here? Okay, now answer for that. That means what? What is u? U is y square minus 4ax. Now do the partial derivation with respect to what? X. Of u with respect to x. So what is supposed to be there? Any one student? This already we have done, right? Partial differentiation in previous lectures. 31 Devanshi. 31 Devanshi. Unmute yourself. Devanshi. Okay, Niket. Niket.
Yes, ma'am. Yes, ma'am.
Yeah.
Yeah, 280 into minus 4 first.
Sorry.
Ma'am, du by del u by del x is minus 4a and dx by dt is 280.
Okay. For only I am asking for what? Del u by del x of this. So this is what? Y square is a constant. So this is nothing but minus 4a. Fine.
Yes,
Okay. And what about dx by dt? Now it's ordinary, right? dx by dt. So what is that? dx by dt?
it's 280. 280.
2at. How? Because x is here, right? 80
Yes,
square. So 2at. So write down in a separate bracket 280 plus del u by del y. Okay, you can mute yourself. Del u by del y. So y is what? Sorry, u is what? Y square minus 4ax. Now del u by del y, that means what? It is with respect to y. So this is supposed to be constant. So I'll write what? 2y. Fine. I'll write 2y. Now dy by dt. dy by dt. So this I need to consider what? This. With respect to what? T. So what is supposed to be there? 2a. Fine. 2a. Now just simplify it. So that is 8 minus 8 a square t plus 4a. And what is the value of y? That is 280. 280. So this is also minus 8 a square t plus 8 a square t. So that is what? 0. Okay. Any doubt? Any doubt in this example? Anyone? So this is what? The composition of one variable, right? Okay. Just a minute. Why that? Okay. Okay, fine. 2y, 2y. Okay. So what happened here? This is called a composite function of one variable. Now, for example, if there will be a three variable here, right? If there will be a three variable here. So what is supposed to be there? Anyone? Three variables are there. Suppose u equal to f of x, y, z, right? And x is a function of something, that is t variable. Y is also a function of t, and z is also a some function of t. So what is supposed to be there? So just diagram is what? I'll write the diagram. I'll draw the diagram. U will depend upon three variables, that is x, y, and z. and all are depend upon one variable, that is t. Now what happened, if I want to find out, if I want to find out a du by dt, that means total derivative of u. Just think for a few seconds and raise your hand, right? Three variables are there for what? U. Okay, but all are depending upon one. So composite function of only one variable, that is nothing but a t. But u itself will depend upon three variables. So how I supposed to write for that? Okay, Jainil, Neil, only this much students know the answer. Okay, Devendra, Vinay, okay, 17, okay, 28 number. 28 number. Yeah, you can unmute now. 28.
Hello.
Yes, you are audible.
Yes, ma'am. We'll just add del u by del z into del z by del t in it.
Not del z by del t. It is dz by dt. See the previous
Oh,
one.
dz by dt, yes.
Yes. So this is remains same. Del u by del x. I'll write down. Del u by del x, right, into dx by dt plus del u by del y into dy by dt. Fine. Plus now del z, sorry, del u by del z into dz by dt. So this is the total derivative of what? U, the equation, right? Now same way the example for that one. Suppose u equal to, okay, I'll write down in the next page. U equal to x square plus y square plus z square. Now where the x equal to e raised to t, y equal to e raised to t sin t, and z equal to e raised to t cos t. Fine. Now find out the du by dt. Simple. Find out the du by dt. So the same one, u will depend upon three variable x, y, z. Now x, y, z all are depend upon one variable, that is t. So what is du by dt? It is del u by del x into dx by dt plus del u by del y into dy by dt plus del u by del z in d, okay, del u by del z into dz by dt. Okay, now you have to consider this x. So now, and this is u. Okay, so del u by del x, partial derivative with respect to x. So x is considered, so the answer will be what? 2x of first term. Now these two are constant, so 0. Now dx by dt. So our x is what? E raised to t. So e raised to t, the differentiation of e raised to t only, right? Plus du by dy. Sorry, del u by del y. So this x and z will be considered as a constant, and del u by del y, this is what? 2y. Clear? Or is there any doubt up to this? Okay, fine. Now dy by dt. So y is what? E raised to t sin t. So now what should I write here? Dy by dt, ordinary differentiation of y with respect to t. So here you can see two functions are there. E raised to t, that means they will be considered as a separate, and sin t. So which rule is supposed to be applied at that? Which rule is supposed to be applied here? Just write down into the chat box, so I'll come to know. Yes, multiplication rule, right? Because what? It's ordinary differentiation you have to do. So what I'll write, that is in another bracket. Okay. So that is sin t, suppose as it is, n into e raised to t plus e raised to t as it is and sine so cos t. So this is the differentiation. Now for z, I'll write here. So obviously it is 2z from the previous one. Now again there will be a e raised to t cos t. Fine. So what I'll do, multiplication rule, cos t into e raised to t minus, plus is there but cos, so you will be having minus sin t. Fine. So I'll write what? Minus sin e raised to t as it is sin t. Is there any doubt in this? Up to this, anyone? Just write down once in a chat box. Is there any doubt? Okay, fine. So, equal to. Now this will be 2x into e raised to t. So what I'll do, now I'll put the value of x also. So x is what? E raised to t. So I'll write what? 2 into e raised to t. This is e raised to t, so e raised to 2t. Fine? Plus 2y. So y is what? Okay. Fine. Y is here 2 into y. Fine. So y is what? E raised to sin t. So I'll put that 2. I'll put here only in a bracket. So it will be easy for us. Sin t. Fine. Now this sin t, that will, as it is, I'll write sin t into e raised to t plus cos t into e raised to t as it is, right? Plus, I'll write now here 2z. So 2 into e raised to cos t, e raised to t cos t plus into cos t into e raised to t minus sin t into e raised to t. Now just simplify it quickly. 2 into e raised to 2t. Just a multiplication. So 2 raised to 2 into e raised to t sin t. So 2 e raised to t e raised to t. So e raised to 2t sin square t plus 2 into e raised to 2t sin t cos t. Fine. Now plus same way 2 raised to e raised to 2t cos square t minus 2 into e raised to 2t sin t cos t. So this thing is supposed to be cancel out this 2, right? Now I'll take a 2 into e raised to 2t common one. So 1 plus, for this it is 1. Now this sin square t plus cos square t. So I'll write down here sin square t plus cos square t. So it is 1, 1 plus 1, 2, 2 into 2, 4, 4 into e raised to 2. Okay, so this is my du by dt, that is total. Is there any doubt into this? Anyone? Any doubt? Okay, fine. So just we are moving to the another example quickly. Z equal to e raised to, write down with me this example. You are supposed to do it. X equal to t cos t, y equal to t sin t. Okay, find out, the question is find out dz by dt at t equal to pi by 2. So just you need to find out this, but at which t equal to pi by 2. Now you can see that z, right? It will depend upon two variable, right? X and y. Fine. Now x and y both are depending upon t. So if you want to find out dz by dt, again these are the two parts. Fine. Composite function of one variable. So what happened here? Dz by dt equal to del z by del x into dx by dt, same equation as the previous example, del z by del y into dy by dt. Fine. Now just count this one. We'll wait for few seconds. You are supposed to write down, right? Meanwhile, I'll check the chat box. Here you can find out the things, right? Del z by del x. So your z is e raised to xy. So you have to consider that. Fine. Just quickly check it. Okay. Okay. So who know the answer? 39 number. 39 number.
Yes, ma'am.
Del
E
z by
raised
del
to
x. Yes.
e raised to xy
Okay, e raised to xy
into y.
into y. Okay,
Y.
fine.
Then
Then,
dx by
yes, dx by dt.
dt is
Hmm?
cos t minus t sin t.
First is,
Cos t minus t sin t.
okay, cos t minus t sin t. Fine. Then, plus.
Plus e raised to x into x. E
E,
raised to xy into x.
e raised to xy into x, right? Here y, here x. Okay. And in another bracket, dy by dt. So this t sin t. So multiplication rule, right? Right? Sin t plus,
Plus
okay,
t.
you can mute yourself. Yes, t cos t. Fine. Okay, you can mute yourself. Now what you need to find out at t equal to pi by 2. So at t equal to pi by 2, what is your x and y? See, just simply put t equal to pi by 2 here. So cos pi by 2, you will get a 0, and y. So sin pi by 2, you will get what? Right, pi by 2. So how you are supposed to write this? Dz by dt, one line, and at t equal to pi by 2. So that is e raised to xy into y. So e raised to 0. Fine. This is. Okay, simplify this first and then we are supposed to put this. So this is supposed to be 0. Fine, because of this, right? No, y is pi by 2. So pi by 2 is there. Fine. Now cos pi by 2. Cos pi by 2 and put the value of t sin t. And here also you put the value of all the things x, y as well as t. So what should be the final answer? Anyone? Final answer of this one? Yeah, Akhilesh. Akhilesh.
Ma'am, it will be minus pi square by 4.
Okay, it will be minus pi square by 4. Okay, any doubt into this? Any doubt? Okay, fine. So, another example of something like this kind of only. Z equal to x square y plus 3x y raised to 4, x equal to sine 2t and y equal to cos t. Now find out dz by dt when t equal to 0. Okay. So here again same thing, z will depend upon two variable x and y. x and y will depend upon t. Okay. So dz by dt. Same equation. Yeah, Akhilesh. Yes.
We have to draw that flow diagram in
No,
exam.
no, no, no. It's for understanding only. So it simplifies your work. That's why. If you know direct, then you can go for that. There is no problem. Fine. Okay. Del
Okay,
z
ma'am.
by del y into dy by dt. Okay. Do this calculation quickly. This del z by del x into dx by dt. Simple one, right? This is what a simple concept of this. Just you have to either do partial derivative or this thing. Okay. So just note down this example. Do it before the next lecture and we'll cross check the answer at that time. Okay. This is the simple one. No need to go in that much detail. Fine. Okay. Just note down in your. Okay, fine, Dev Patel. It's noted down. Okay. Now, composite function of two variable. Instead of that, one, two variable. Fine. That means what? At that time, your z is f of xy. Fine. Where x itself is a function of two variable. In previous it was what? X is a function of only one variable, that is t. Now x and y both are the function of two variable u and v. So how we can draw the diagram for that? Z will depend upon two variable x and y. Now x itself will be depend upon what? U and v. So I'll write v and u. Now this y is also depend upon u and v. So this is common u and v. So this is the thing, right? In both, it will be written as a what? Separately they have mentioned, that is z will depend upon x and y. So both are the correct one. Now this x and y is depend upon what? U as well as v. So in that way xy is depend upon v. So this two diagram can you consider as a this path, right? Same thing you can go for the y. So this is in only one diagram. So this, if you are writing in this way, then it will be easy for you to writing down what? The final answer, right? That's why. So if you want to find out, now you can't write dz by du directly or dz by dv, right? So it should be what? Del z by always del v. There are two equations you will be getting here. Del z by del u. Okay, it's not now d, it is what? Del z by del v and del z by del u. Why? Because there is no path. Okay, meeting may be end in few seconds. No need to rejoin again. Just this is for the concept. Two variable. We'll continue with this topic only in the next lecture, right? So this is the thing. Just try to write down yourself. Okay. So we'll see how much you got the understanding for from this lecture. Okay. Del z by del v and del z by del u. Instead of d here, del is there. Fine. Okay. So just write down yourself. Try to write down this. Now, is there any doubt up to this?